Good. Good morning, everyone. Welcome to the last day of the Nigerian Peering and the Connection Forum. It's been a long haul, 3 good days stretch. First day was the bootcamp section 1. We had the bootcamp section 2, and then we had the conference yesterday. Today is the last section, and we'll be focusing on manners. I am calling on the moderator, Portia, who's going to moderate this section. Hi, Portia. Nice to see you again.
Hi, Joshua. It's nice to see you too.
Grateful.
Okay.
Over to you.
Should I take over? Okay, great. Hi, everyone, and welcome to the Nigerian Peering and Interconnection Forum. Today is the last session. It is Bootcamp Session 4. And for the Bootcamp Session 4, we are going to be talking about mutually agreed norms for routing security, also famously known as MANRS. So before I introduce our speaker or presenter, I'd just like to encourage everybody to please interact as much as possible. This is an interactive session, so we'd really love for you to please send your questions when you have them, but we'd like to ask that you please use the Q&A function, because we'd like to have chats and have everybody greet each other in the chat section. So please use the Q&A function to send your questions so that they do not get lost in the chat. So without further ado, I'm just going to introduce our presenter for today, who is Musa Stephen Honlue. He is from Afrinic, and he is the project manager and transformation lead. Musa is a network system engineer, and he has been serving in the internet community in various ways, like creating content to educate technologies, protocols, and various practices, delivering training both in face and online settings for various internet organizations such as Afrinic, ISOC, and AFNOC. I'm sure you have seen him at some of these conferences. He also delivers webinars, technical presentations, as well as assisting to organize deployments for various technologies such as IPv6, RPKI, and DNSSEC. So Musa, like I said, he is with Afrinic, and he also helps with training and certification project management. And without further ado, I'm going to ask him to please take over the session for us. Musa, are you ready?
Hi, Portia, I'm ready. Thank you for that introduction. So I will start right away by sharing my screen.
I'll just confirm once we have your screen on.
I guess you have it right now.
Yes, if you could please go into presentation mode, and then we're ready to go. Perfect.
Are we good now? Okay.
Yes,
so,
we are good.
So my name is Musa Stephen Honlue, and I will be talking about manners. And as Portia said, we would like you to participate as much as possible through questions, remarks, and how you feel the session. So greetings to everyone. So this is the agenda that we will try to cover in the 1 hour 30 minutes. At the end of it, if we still have time, that is obviously not possible. But if we had time, we'll be able to do a demo on an online lab where we will configure things like EU NICAS reverse path forwarding and some filtering. So we'll start by presenting some of the routing security incidents, including route leaks, IP spoofing, route hijacks. And we'll present the solution that we are here to sell. That is the MANRS for network operators, IXPs, clouds, and CDNs, and also for vendors. And then we'll look at the MANRS actions for network operators, that's filtering, anti-spoofing, coordination and global validation with tools like IRR and RPKI. And then we are going to present you the MANRS raw tools, which is like an online portal to present with statistics on MANRS participation. And we also present you the MANRS observatory. That said, these slides were done thanks to contribution from many people: Naveen, Aftab, Dr. Philip Smith, Tashi, and Zober. So we would like to thank them for helping. So what's the problem? As you may know, BGP was conceived without incorporating security. So it's a protocol that is based essentially on trust. So if IXP, two network operators, A and B, are planning to peer, they will share their resources. And resources here are AS numbers and their IP blocks, IPv4, IPv6. And the two are going to like peer together and start announcing their prophecies. What the two are going to do is either propagate the prophecies depending on the contract agreement they have, and so on. So at the very base is trust. So A trusts B, B trusts A, that the resources they say is theirs belongs to them. That is the AS number and the IP blocks. So with this, there have been a lot of progress, of problems on the internet. And I'm going to present those problems right now. So this is an example of routing incident that happens a couple of weeks back. And it was with Global Communications that leaked almost 167 prefixes, and they affected like 9,000 autonomous system numbers in 193 countries. And so the AS 137996 announced these prefixes to their new providers, and that, as you can see in the graph here, you will see like a peak of announcement at a certain point, and this made news over the internet. Another routing incident was Vodafone Idea. So they started originating more than 31,000 routes, which did not belong to them. And their main upstream, which is Bharti Airtel and Vodacom UK, allowed the wrong routing advertisements to go out there. So you can look at the graph and see at the point where we had that peak of communication of more than 31,000 IPv4 prefixes being advertised out there. So we have like three major problems. Two of them linked directly to IP routing, and one of them linked to IP spoofing. So we have a prefix or route hijacking, and we have route leaks, and then we have IP address spoofing. So what's a prefix hijack? If you look at the graph, you see the AS in the middle. That's AS 500, has two customers, customer 1 and customer 2. So customer 1 happens to have these two prefixes, that's IPv4 and IPv6, and customer 2 happens to have their own two prefixes. So in a ideal world, what will happen is that customer 1 will send their prefixes to the upstream provider, and the upstream provider will propagate it into the internet. And anyone on the internet which is looking for resources, in one of these prefixes will direct it to 64,500, and 64,500 will direct it to the various to the customer. At a point in time, someone on the internet, an organization or maybe any user, decides to originate the same prefix. This could be due to misconfiguration, or it could be intended. So if their provider, if their transit provider decides to propagate that into the internet, now some users on the internet will start believing that the prefix 192.0.2.0/24 is somewhere here. So at best, part of the internet will believe that that prefix is sitting in AXX, while another part will believe that it is sitting back here. And this will cause a lot of disruption on the internet. So there are two ways of doing prefix hijack. So you can hijack the entire block, or you can hijack a more specific block. And when you start hijacking a more specific block, that block is being preferred. This is the rule in BGP. The more specific is always a preferred route. So the most famous route hijack that happened on the internet happened in 2008 with the prefix of YouTube that got hijacked by Pakistan Telecom. So the story goes like this. There was a video on YouTube, and the government of Pakistan was not happy with that video. So they asked YouTube to shut down the video, and it didn't go the way they expected. So they asked their Pakistan Telecom to make sure that YouTube is not accessible in the country. What Pakistan Telecom went and did was they announced the prefix of Pakistan Telecom, of YouTube. And by announcing that prefix, users on the internet also started believing that YouTube was relocated in Pakistan. And this happened because their upstream provider, Tata Telecom, Tata Communication, did not filter their announcement. If those announcements were filtered, the internet wouldn't have suffered that outage. So it was a very huge outage for a long period of time while YouTube tried to counter the attack. So you see, this was not like a malintention. They were trying to stop a video to be seen in their country, and they went the entire YouTube went down. So if you go to BGP Stream, bgpstream.com, right now you will see a lot of route hijacks that are happening on the internet. So I just captured this one. This one was so the prefix 103.109.211.0/24 is normally supposed to be announced by 133.995. All right, but beginning the 11th of September at 5, the same prefix, that's the 103.109.211.0/24 was also announced by AS64553. All right, so this was detected by BGP-Mon. So BGP Stream is a tool that relies on BGP-Mon. BGP-Mon is like a daemon that monitors BGP transactions and announcements. Another BGP hijack, but now with a more specific route, happens like on the prefix. The prefix is 172.32.0.0/11, and someone decided to advertise a more specific, that's 172.32.0.0/23. So this will be preferred over the bigger block, which is a /11. Some other prefix hijack, if you go on bgpstream.com, you will see all of this. So that's the first route incident type that we have. That's routing hijack. Now let's look at route leaks. Route leaks here we still have the same upstream provider with the two customers, customer 1 and 2, with their same blocks. But now see what is happening here. We have YouTube. YouTube is Google. Google is advertising the prefix 8.8.8.0/24. It gets to AS64500. He can advertise this prefix. He can propagate this prefix to his two customers. But at a point in time, customer 1 has two upstream providers, ASB and AS64500. It is learning the route through the two upstream providers. For some reason, it decides to advertise that route, to propagate that route to their upstream provider, who is 64500. What happens here is 64500 start believing that there is a better route to go to, 8.8.8.0/24, and that route is through their customer. They will now advertise this to all their other customers, that there is a preferred route to reach Google, and their customers will now start sending traffic to the internet through that other customer. So this is very detrimental because, you know, customer here is paying for their bandwidth, and they will now start supporting, they will now start acting as a transit provider to their upstream provider. This is very bad. So an example of a route leak happens in June 2019, where allegedly leaked routes from one of their provider to the other provider, was Verizon, causing a large outage. So you can read, there is a blog on that, on a blog post on that on Cloudflare's website, so you can read it. The slides will be shared with you, so you can see that. So this is an example of route leak still on the website bgpstream.com, and you can look at it. So this example is beginning 24th of June. At this time, BGP-Mon detected that there was a possible leak. So the prefix 112.198.30.0/24 is supposed to normally be announced by AS4797, all right? And that's the name of the operator, but it got leaked by AS4775. This is Globe Telecom. And yeah, so this is an example of route leak. Now, some example of incidents happening with regards to Nigeria, okay? Since we are in Nigeria, let's talk about some incidents that are happening in Nigeria. So in terms of BGP hijacks, we have these three that we could find on the BGP stream website. So the prefix is 197.255.209.0/24. So this is same lane, same lane, and a more specific. So you can look at them. These three prefixes were actually hijacked. So some of them are still ongoing as we talk right now. So you can go on BGP stream to look at. An example of BGP leak happening on the prefix 441.222.150.0/24, again in Nigeria. So you can go to BGP stream and you will see. So these are the incidents. So I presented two incidents here, two types of incidents there: BGP route hijacks and the BGP route leak. So what are the tools that are available to counter this type of incidents when they happen, or to correct them so that they have less or non-impact on our networks? So we have prefix filtering, ASPAT filtering, we have the IRR system, we have the RPKI, we have BGP-SEC, which is now a standard documented by the IETF. But the problem is it is not yet implemented by most vendors. So we still rely on some of those tools that I named, like the prefix filtering, ASPAL filtering, IRR, and RPKI. So let's look at the solution that I'm here to talk about, the mutually agreed norm for routing security, MANRS. So MANRS is just one of those fancy names, you know, engineers like to give to some of the easy things that we do. So it is a set of actions, and it is a set of programs that are documented to help network operators, network engineers to make sure that we together, that is mutually, we secure the global routing table, that's the internet. So it is meant to improve the security and the reliability of the global internet. So MANRS is a set of 4 programs, right? We have MANRS for network operators, MANRS for internet exchange points, MANRS for content delivery networks, and MANRS for vendors or manufacturer. So the latest one, the last one, the MANRS for manufacturers just came in this year. So the first one, that's the MANRS for network operators, is a program that was launched in 2014. And it was a group of network operators that came together, and they noticed that, all right, individually we can secure the internet, but if we come together and we agree on a set of actions, we can better secure the internet. So it is a set of actions that I'm going to share with you soon. So those actions are filtering, anti-spoofing, coordination, and global validation. So as a network operator, if you implement action 1, 3, and 4, you are MANRS compliant. So action 1 is filtering. Filtering is we make sure that all what we are advertising to the internet, all what we are propagating to the internet, we filter. We filter to make sure that we don't advertise a prefix that we are not entitled to advertise. And we filter inbound, that is what we are receiving, to make sure that we don't accept garbage from the internet and we don't propagate this wrong information to the rest of the peers that are peering with us. The second action is anti-spoofing, which is not a compulsory action, but is very, very important to fight things like DOS attack and DDoS attacks. So it is basically us making sure that the IP packets that we receive in our network, before we propagate them, before we forward them, we verify that the source IPs are not spoofed. Action number 3 is coordination, where we facilitate sharing information about our organization, about the resources that we hold, about the people that manage these resources. We share all of this information either on our website, on websites like PeeringDB, and so on and so forth. And action number 4 is global validation, where we use systems like IRR and RPKI to make sure that what we are accepting in our network is actually the right information. So you can look at the implementation guides of MANRS on their website. That is manrs.org/ISPs/BCOP, best current operating practices. So the second program, that is MANRS for Internet Exchange Points, came in 2018, and it is a program that is meant to focus on specificities on the Internet Exchange Points. So we are looking at what an Internet Exchange Point should do to protect their infrastructure and protect all the members that are appearing at the Internet Exchange Point. So MANRS for Internet Exchange Points is a set of 5 actions. Action 1 is to prevent propagation of incorrect information, right? So if you're having, let's say, a route server or a route collector, you make sure that every information that you receive, you filter before you propagate to the peers in the Internet Exchange Point. Action number 2 is promote the MANRS actions with the IXP's members. So encourage ISP members to implement the MANRS actions, and make sure that you are there to support them also if they need the support. So these are the 2 compulsory actions. The other 3 actions are not compulsory, but they are very important to make sure that we keep a secure routing table at the internet exchange point. So action number 3 is you have to protect the peering platform. As I said earlier, when people are peering at your internet exchange point switch, make sure that there are some types of traffic that you don't just accept, and also make sure that your route collectors and route servers are serving the appropriate information to your members. Action number 4 is to facilitate the global operation and communication. So this, you can do this by making sure that you have like a mailing list where your members discuss about this MANRS actions, and you can also like publish like policies on your website and informational portals. And action number 5 is you make sure that you provide like a monitoring system that can help your members to debug when they have any problems. So for the implementation guide for the IXPs, you can go to manrs.org/IXPs. The third program here was launched in 2020. As you can see, the MANRS team is really working hard to make sure that we bring as much documentation and programs to all network operators, whatever group you fall under. So the third program here is for content delivery and cloud programs. So it is meant to create a very secure environment for the cloud providers and CDNs. So it is a set of 6 actions, and you will see some of the actions here are the same as those for the internet exchange points. So the first one is to make sure that you prevent all incorrect routing information to be propagated. That is filter, filter, filter. And action number 2 is prevent that spoofed IPs. So if users are trying to access your content with spoofed IPs, make sure that you block that. The receipt chat, is it a question? All right, thank you, Yusani. And so action number 3 is to facilitate global operating communication. Make sure that you have maybe a portal where you share about all of this information. It could be on your website, it could be on the peering DB, and also make sure that the IRR databases are up to date with regards to your information. Action number 4, you need to facilitate validation of routing information. So make sure that you have consistent information both on the Internet Routing Registry and the RPKI. Action number 5, you need to actively encourage your peers. So those who you peer with, encourage them so that they can also implement the MANRS actions. And action number 6, make sure that you have like a monitoring platform so that people that are other operators that are peering with you, they can have information on how to debug and solve problems in case they occur. So now let's focus on MANRS for network operators, since this is the most popular program. So it is a set of 4 actions, as I said earlier. It is filtering, anti-spoofing, coordination, global validation. Let's start with filtering. And filtering, if you want to learn like more about filtering, read the BCP 194, which is also RFC 7454. Why do we need to filter? Why do we need to filter? if we start doing, when we start peering and everyone is advertising what they want, we receive all type of information. Some of them are good, some of them are bad, some of them are even very, very bad. So when you are peering out there with, let's say, your upstream provider and other peers, maybe at an internet exchange point, you are your first line of defense. So you need to make sure that what you are getting is correct information. You are also the first line of defense of the internet, because what you get, you will propagate out there. And if you are propagating wrong information out there, people will believe that this is good information, and this will go ahead and cause things like routing hijacks, route leaks, and there will be outages out there on the internet. So it is very important that all of us, we start filtering. Actually, when we teach courses like building scalable network internet infrastructure, we actually say the golden rule for BGP is filter. So filter, filter, filter. Always make sure you filter, because don't be the source of wrong information propagation on the internet. So when you do that, you avoid other networks to believe in the wrong information you are sending, and you avoid also outages on the internet. So if you want to see information about best practices on filtering, you can also go on the MANRS website, ISP's guide filtering. You have a lot of information there. So basically, this is the network diagram that we will be using throughout the presentation. So we have a network operator 64500. This is our network. We have two customers, 501 and 502. We have a peer, which is this can be any network in let's say in an IXP, an internet exchange point, and then we have our transit provider. Okay, so good. So why is filtering important? So I already talked about this, so let's just skip this. When implementing filters, you implement this to make sure that incorrect routing information is not being propagated, right? So when you implement this, you deny information, prefixes that are not meant to be routed on the internet, and AS numbers that are not meant to be routed on the internet. And filtering happens inbound and outbound. Inbound, what are you accepting from, let's say, your customers, from your peers, from your transit provider? It is important to define that. Outbound, what are you advertising to your customers, to your peers, to your transit providers? So you need to think this throughout fully and make sure that what you are advertising is actually consistent and it is what's supposed to be advertised. So now, when filtering outbound, right, you should make sure that the prefixes that you are sending outbound are your prefixes and the prefixes of your customers. Make sure you are not advertising the prefixes of your peers, because if you start advertising the prefixes of your peers, you become a transit for them, a transit provider. That could cause something like a leak. That could be a route leak if you start advertising prefixes of your customers, actually of your peers. Actually, some peers will be happy if you do that mistake, because they will start using your bandwidth. And if you have a good bandwidth, they can start using it. So don't advertise prefixes that do not belong to you or your customers. Don't advertise prefixes. So prefixes that are coming from your upstream provider, you can now propagate it to your customers, right? You can propagate whatever you want to your customers, but to your upstream provider and other peers, don't do that. So when you are filtering, bear in mind that on the internet, for IPv4, we don't want to see prefixes that are greater than /24. So don't advertise /25, 6, 26, 27, and so on for IPv4. For IPv6, Don't advertise anything that is more specific than a /48. All right. So these are recommendations. These are best current practices. So still on filtering, I already explained that when you are filtering, what you are sending to your customers, depending on the agreement that you have with your customers, you could be sending them the entire routing table. If you are sending to them the entire routing table, make sure that you filter out all bogons. Bogons are prefixes that are meant for like private networks. That is documented in RFC 1918. There are some special prefixes that are not yet allocated, so don't filter them out. There are prefixes that are not yet allocated and they are still at the regional internet registry like Afrinic. Don't filter those prefixes. There are prefixes meant for special use like documentation. Filter them out. So make sure you filter all of this before you send them to your customers. So to your customer, if you are sending them the global routing table, don't send the default route. All right. But if you decide to send the default route, do that. So you send depending on the agreement that you have with your customers. To your peers and maybe other ISP, if you're an ISP, maybe in Nigeria, you are peering with other ISPs to make sure that we keep the local content local. So to these peers, make sure that you are sending, when you are sending, make sure that you filter anything and you send only your prefixes and the prefixes of your customers. This is all what you have to send to them. Now, maybe you have some other interesting stuff in your network, like let's say you have a cache like Akamai cache and things like that. You can also send them those types of prefixes, but have an agreement and decide on what you want to share with them and share only what you've agreed to share with them. To your upstream provider, the only prefixes that you want to advertise to your upstream provider is what? Your prefixes and the prefixes of your customers, nothing else. Now, inbound. So I said when you're doing filtering, you have outbound filtering and you have inbound filtering. So inbound, filter out all bogons. Bogons in terms of prefixes, bogons in terms of ASN, and don't accept your prefixes and the prefixes of your customers. Now, if you requested for the global routing table or partially, you want to deny the default route, all right? And also like avoid two specific prefixes. I said in terms of IPv4, don't go too specific above /24. In terms of IPv6, don't go more than /48. And it is actually advised that when creating filters, use the information that is in the Internet Routing Registry. You can use tools like BGP Cure3 or BGP Cure4 to actually create your prefix list. So this is a more specific example, and I will be skipping this. You will have the slides because it is a lot of configurations based on Cisco syntax. So you will be able to see this on the slides. Yeah, so this example is just showing us that for the various customers, for the peer, what prefixes
We apologize for that interruption. We seem to have lost Musa there for a bit. I'm sure he will be rejoining us as soon as there we go. Hi, Musa, welcome back. You're on mute. Please unmute. There we go.
Sorry for that. So
Welcome
where did
back.
I stop? Where did I stop? I don't know. When did you stop hearing from me?
I think you can restart at the slide.
Okay, good. Thank you. Internet these days. So yeah, so on this slide you have a lot of information on what prefix you need to accept, what ASNs you need to accept, and the prefix length as well. So configuration. Yeah, I explained this already. The longest prefix you need to accept in IPv4/24, IPv6/48. So today on the in the global routing table, we see a lot of things that are happening. People advertising /64s in IPv4, in IPv6, and /32s in IPv4. This is very bad. So let's avoid all of this. Now, in terms of filtering, I just presented filters with IP prefixes. You could also do filtering using ASPATs. So, and when you are using ASPATs, it is also good to master the regex language where you can write regular expressions. So for instance, I will take the example I have here. IP ASPAT ISList 10 permits, carrot, and dollar. So this is basically the carrot is the start of your string, and the dollar is the end of the string. So I'll go further and take an example. Yeah, so this example says that we permit a prefix advertisement with this ASN alone. That is, it is originated from this ASN and it has not crossed any other autonomous system. So you see, it is saying that it starts with 64501 and it ends with 64501. So this is an example of ASPAT that we can apply on a customer, because if we're having our customers, we don't want them to be advertising things they are learning from other networks to us. We want them to advertise only things that they originate from their network, their prefixes. So this ASPAT filter will actually achieve that goal, where we don't want our customers to start advertising stuff they are learning, we don't know where, to us. So max prefix filtering also is recommended that you limit the number of prefixes that you are learning from a single peer. So you can configure that by using the max prefix filtering. It is documented in the BCP 194, which I presented earlier. So it's good to read that BCP to understand all the details on maximum number of prefixes that you are receiving from a specific peer. So this is the syntax, the configuration syntax for Cisco. An example here is for neighbor x.x.x.1, the maximum prefix that we want is 3000. So when we have more than this, we will drop, right? We'll drop the peering session and we can refresh. We can restart the session after a period of time. So we can drop, we can log, or we can restart the session. So the first one is drop. The second one is a log, a warning, so that the network engineer can view the logs and see actually what to do. And restart, that is the third one, is to restart in 30 minutes. So the session is going to stop and restart in 30 minutes. All right, so you can also filter based on SIDR, that is secure inter-domain routing, right? And yeah, so this is, I'm going to talk about this more when we view when we see RPKI soon. So the summary here is only accept prefixes that are sitting in the Internet Routing Registry database. So if someone says AS XYZ and I want to send to you prefix x.x.x.y, go to the Internet Routing Registry, verify it, and make sure that there is a route object that exists for this prefix. And we are going to see this route object soon again. When advertising on the internet or receiving prefixes, make sure that for IPv4, you don't accept anything that is longer than /24. For IPv6, anything that is longer than /48. Use RPKI to validate. And I'm going to discuss this further in the section about RPKI. And filter out inbound and outbound the bogons. And yeah, that is it. So if you want some data source, you can go on Affinity website. You can look for support there. You will have support. You have the peering DB for AirSets. So you can go on peering DB website. Team Kimru is doing an amazing job providing bogon lists for both IPv4 and IPv6. So you can look there as well. So this is an example of, as I just told you earlier, that when you are peering with any organization, make sure that they have a route object in the Internet Routing Registry. So this is an example with the prefix 196.192.0/16. So you can see if you query the whois.affinity.net against this prefix, you have the INET name, which is it's a /16 here. And you see that there is a /20, there is a root for a /20, that's 196.192.0.0/20. And it is used by Mauritius Telecom, and it is authorized to be originated by AS 23889. Okay, so this is it. Building your prefix list. You can build your prefix list by using a tool like BGP Cure Tree. So this is an example that I just took with the AS 20597. Okay, so it is a tool that is easy to use. You can download and install, and it is sitting on many of the repository, like the Ubuntu repository, where you can just do an apt-get install, BGP Cure 3 or BGP Cure 4. I will actually recommend that you use BGP Cure 4 because it comes with a lot more of features, like the support of more operating systems. So this is still us demonstrating how to use BGP Cure 3 to build your prefix list for Cisco, for Juniper. Yep, so this is it. Still using BGP Cure 3 to build for Birds, for Juniper, for Cisco, for IPv6. Yeah. There you go, still BGP Cure 3. So as I said already, you can have documentation on the list of bogons on the internet. Team Kimru has references that you can use, and you actually see the list of prefixes that you are not allowed to advertise or accept in your network. All right. Okay, so these are the list of ASNs that are bogons. Like you see ASN 0, which is reserved. So don't accept announcements from this ASN. You see ASN 23456, which is a transition ASN between the 16-bit ASN and 32-bit ASNs. you see this block from 64496 to 64511. They are reserved. They are used for documentation and coding. So yeah, you have all the lists of bogon ASNs here that you don't want to accept in your network or propagate. So an example of ASPAT list, AS list, access list. So you have it there. This is built, you can build this using, again, the tool BGP Cure 3 or BGP Cure 4. So you can also go on the entity website where you will see a lot of documentation on policies on how to filter ASNs. You can also pair with Team Kimru. You can also pair with Team Kimru if you don't want to like create the AS list, all of those. You can pair with Team Kimru, and they will fit you with the list of things that you need to filter in terms of either ASNs or prefixes that you need to filter. So you see this, this Team Kimru is really doing an amazing job. So that was filtering, and I will pause here to see if there is any question. Are there any questions?
There's currently no questions, but we'll encourage our attendees to please raise their hands or to send in their questions now if they do have a question. Everyone, you're welcome to send your questions through to Musa. You can raise your hand if you'd like to say the question verbally, or otherwise you can just send it through to the Q&A and we'll read it out loud and he'll respond. Okay, Sarah says she does not really understand the topic.
All right. So, Sarah, we are discussing how to secure the global routing table. And we said there are 4 actions we need to take. All right, Sarah, don't worry. We said there are 4 actions we need to take, right? The first action is filtering. That is filtering what we are advertising to the internet and filtering what we are receiving from the internet. That is what we just discussed up to now. So the slides are as well as the recording are going to be shared to you so that you can go through them again. And if you have any questions, you can send them to me. My contact is on the first slide, so you can reach out to me for further explanations. But yeah, the first thing is we just discussed how to filter, what to filter, and rules to filter. Okay, what you need to filter in terms of the prefixes that you are originating to the internet, and what you are receiving. Okay, so there was a question in the Q&A. It is answered already. Okay.
It was good. Just regarding the slides, which you have answered already.
All right, thank you. Okay, so now, Sarah, my contacts will be, I will share the slides and my contacts are on the slides. So now let's look at the second action. The second action, which is anti-spoofing. So what is spoofing? Spoofing is when someone decides to impersonate someone else's identity. And here we are talking about IP spoofing. So I can decide right now that Portia is running the network of, let's say, Flex Optic, and I decide to, you know, steal her IP addresses, either to use in my network or to to tamper with her network. So I can decide to forge IP packets right now, send to the internet, 1,000 of them, thousands of IP packets, millions of IP packets I send to the internet with her addresses. What will happen is that those who receive those packets will start responding to her, and she will receive a lot of packets. This is a storm of IP packets. When she receives this storm of IP packets, what will happen is that she will stop answering to legitimate requests, and she will now focus on this storm of packets. When I do that, what I'm achieving is I'm doing a denial of service. It could be a denial of service, a normal denial of service, or a dynamic denial of service. All right. So this is why spoofing is very, very bad. And we should implement an action to stop spoofing. So if you look at the BCP38, BCP38 actually documents how you can stop spoofing in your network. That is implementing anti-spoofing. And if you go on the website of Qaeda, that is spoofer.qaeda.com, something like that, you will actually see all the networks that are actually doing the anti-spoofing in their network. Go on that website. Let me just type Qaeda. All right, yes, thank you, Naveen. So if you go on that website, you will be able to download that tool, run it in your network to see if your network is actually implementing anti-spoofing. Okay, this is very important. So now I will discuss further about anti-spoofing. So it is also documented in RFC 2827. So source address validation is what we call anti-spoofing. It is actually when you receive any IP packets, you verify the source to make sure that the IP that is there, it is not a wrong IP. It is not an IP that was stolen. It is not an IP from the wrong source. All right. So make sure that you filter this to avoid things like spoofing and denial of service. So there are actually two ways of implementing source address validation or anti-spoofing. You can use ACLs or you can use unicast reverse path forwarding. If you are using ACLs, it means that you have a list of prefixes. You create an ACL where you have an entry of all what is authorized to be accepted in your network, and you apply it on the right interface. If you use ACLs, this becomes a bit cumbersome because it is tedious and maintenance is not easy. If you have a very small network, that works well. And it is actually a very good solution, but just that maintenance is not easy. The second way of doing the anti-spoofing is by activating unicast reverse path forwarding on your router. So most vendors today, like Cisco, Juniper, MikroTik, they actually provide this feature. So you just go and enable it and it will be good. And there are actually many modes of doing this. You have the loose mode, the strict mode, the feasible mode, and the VRF mode. So the loose mode, in the loose mode, if you enable the loose mode, what happens is when you receive a packet, the router is going to verify that there is actually an entry in the routing table, no matter where that entry directs you. If there is an entry in the routing table for the source network, good. In the loose mode, we are good. We are going to accept that packet. Strict mode, in strict mode, we make sure that there is an entry in the routing table and that entry is pointing to the receiving interface. So if I receive a packet on a specific interface, I want to make sure that I can reach that network, the source network through that same interface. That's the strict mode. The feasible mode is when you have either a route in the routing table or you have a feasible route. All right. And then the VRF mode is same like the strict mode, just that here you are dealing with VRF. You know, VRF when you segment your router in various VRFs. So with this example, I'm going to present the strict mode. Look at the first diagram. The first diagram here where we receive a packet from 192.168.255.1. So this is actually an IP in the network 192.168.255.0/24. And if you look at our routing table, we actually have an entry for that, right? We have an entry 192.168.255.0/24 pointing to interface gigabit 0/0, and we are receiving that packet on interface gigabit 0/0. So we can reach that network through that interface. So we are going to accept this. Look at the second diagram. In the second diagram, we are receiving a packet from 203.0.113.1 on interface gigabit 0/0. We have an entry, right? We have an entry for that network, 203.0.113.0/24. The only thing here is that it is pointing on gigabit 0/1. That is not where we are receiving this packet. If we're in loose mode, we would accept this. But since we are in strict mode, this is not matching the interface, so we are going to drop this. So this is an example of how strict Unicast URPF works in strict mode. Now let's look at the configuration. So for strict mode, if you look at the configuration here, we are saying IP verify unicast source reachable via RX. RX stands for receive. So that source address should be reachable via the receiving interface. So we are enabling, you can see we are enabling for both IPv4 and IPv6. You see, we are doing this for Cisco and we are doing this for Juniper as well. So Juniper, you just do RPF check for both IPv6 and IPv4. Now, when you've enabled that, you can verify by using the show IP interface gigabit 0/0. And here you see, you can see URPF here is in check, right? And we can see here IP verify source reachable via RX. And we can see that 5,000 packets were dropped due to this. So we have actually 5,000 spoofed packets, all right? And you can also do show IPv6 interface to view for IPv6. So for IPv6, we can see that, yeah, it is also enabled. And we have around 19,000 packets that are being processed with regards to this, this URPF. Still with regards to verification, show IP interface, gigabit, include drop, we can see the number of packets that are dropped, right? For both IPv4 and IPv6. So in loose mode, how do we configure loose mode? Remember in strict modes, reachable was via RX, right? Via receiving interface. Now we are saying reachable via any interface. So we just need to have an entry for that source address in the routing table. So we just done with enabling anti-spoofing via URPF. Now enabling this via ACL. These are the recommendations. So we need to manually configure ACLs to filter out every packet that we receive from specific IPs on specific interfaces. So we will do this towards our upstream providers, towards our network, in our network, on the interfaces that are connected to our peers, and so on and so forth. So this is an example of ACL. As you can see here, we created the ACL extended from customer one. So from customer one that we have here, we want to permit 192.168.0.0/24/16. We want to permit that to any. We also want to permit 10.0.0.0. This is a /8 to any. And we want to deny any other IP packets that is going to that customer. And look at what we are doing here. We are applying this to gigabit 0.0 inbound. So the rule is to make sure that we drop the spoof packet as close as possible to the source. We don't want them to be propagated. So we drop them as close as possible to the source. So another example of ACL here is with Juniper. So that is it with anti-spoofing. Do we have any questions? Any questions with regards to anti-spoofing? So as you can see, anti-spoofing is very straightforward. It's very easy. You actually just need to enable unicast reverse path forwarding on your interface, and you are good to go.
There are currently no questions, Musa.
Pardon?
There are no questions so far.
All right, so let's move on to coordination. So coordination is actually very simple. It's very easy. It's you, network operator, making sure that you document your resources, you share your information about your contacts on the appropriate portals. So you can put this information using your up to date. Make sure that your information are up to date. Put it on your website. Put it on the IRR database. Put it on portals like PeeringDB and so on. So yeah, this is just what I was talking about. So for Afrinic region, make sure that you update the WHOIS database. The WHOIS database, which is the same thing like as the Internet Routing Registry database for our region. PeeringDB is also a website, is also a very good website where you can go and document, put your information about your contacts, so that if there is any problem with your resources out there, people can easily reach out to you. And also put your information up to date on your website. So this is the PeeringDB website, where you can see this is an example of this is an entry for Fiber at Home Global, and you can see their information here. At the left hand side, you have their contacts, so you can reach out to them if you have any problem with their resources. And at the right, you will have like information about their peering facilities, the exchange points where they are, and so on and so forth. So everything is there. You will have their ASN, their resources, and so on and so forth. You can also have this information on the WHOIS. So like if you just go and query, let me actually do a demo here. I'll ensure, stop share my screen, and I can share I can share my terminal. So here, so whois is actually a tool that is installed in most of the Linux operating systems. You can also install it, and it will help you. You can use it to query the whois database. So if I say whois.afrinic.net, and I'll pick let's say AS 1, say 3369, for instance. So you see, it will give me information about this ASN. So this is actually an ASN, and there is an AS block that is having this as member. Okay, so I have this information, I have the ASN itself, and it is telling me that it is the pen house. You see, I can have their incident response team, which is interesting. I have the email, how to reach out to them. All right. I could actually make it more verbose to have more information. And you see organizations, everything. And there you go. So this is how you can use this tool. You can also like go on directly on the, let's say, the Afrinic website, that is, you can go directly to whois.afrinic.net. So you can try and open that website, whois.afrinic.net. If you open whois.afrinic.net, you will be able to see, yeah, like here, if you type, let's say, the name of your organization, let's say I can type Afrinic. If I type Afrinic here, I will have information about Afrinic. So I can see that this block is allocated to Afrinic. This organization is Afrinic African Network Information Center, Afrinic Ltd, and so on. So I will have a lot of information about them. So this is why we are recommending that on the whois.afrinic.net, you make sure that your information is up to date. So where are my slides? So that is basically it for global coordination. So it's all about you making sure that your information is up to date. So question, spoofing can apply to emails, phone calls, and websites, and so on. So how do I admit it is spoofing via the following? ARP and DNS, please explain in details by giving examples. So here, the spoofing we are talking about is IP spoofing, right? We are talking about IP spoofing, whereby any IP packet that you receive, you make sure that the packet, the source address, is not a spoofed packet. So as you said, spoofing can happen via email and so on and so forth, whereby when you say via email, I don't know if you're talking about spoofed emails, whereby someone can spoof someone else's email address. But I will dwell in explaining spoofing using DNS systems. So, you know, there are many DNS resolvers out there on the internet. I can decide that I will query a specific DNS server. Let's say I can query 8.8.8.8.8. And to query this server, I will send an IP packet. And in that IP packet, there is a source address, which is my address, and there is a destination address, which is the address of that server. That server will resolve and send back the response to me. Now I can decide that instead of using my address, I will use your IP address. When I use your IP address and I send that forged packet to that DNS server, that DNS server is going to respond to you. So I can decide at that moment that I will send 1,000 of these packets, these forged packets, with your IP address to thousands of resolvers out there in the internet. And all of these resolvers are going to send back their response to you. So that's how you can use the DNS system to forge an IP spoofing attack. So you can use IP spoofing combined with the DNS system to attack a specific server out there on the internet. I don't know if this example resonates with your question or you need more explanation. Olumide? All right. Okay. Yeah. So that's how you can use the IP system, the IP spoofing. So, and you know, today to forge packets is very easier because attack tools have become very sophisticated, and it's very easy for anyone with little knowledge in networking to use those tools and perform those attacks. So this is why we are calling upon your attention so that you take this into consideration and you make sure that you are protecting your networks and protecting those that you are caring with. So coordination again, coordination. Now let's look at the fourth MANRS action, which is global validation. So global validation is a way to facilitate validation of the routing information, that's the information that we are propagating in the internet. And we are going to do this using two systems, the IRR system and the RPKI system. So, as I said, there are two systems, right? The IRR system and the RPKI system. So the IRR stands for Internet Routing Registries. So it contains a lot of information, and it is being managed by the regional internet registries, that is AFRINIC, ARIN, LACNIC, EPNIC. And you also have like third parties like Entity, RADDB, all right? So we have this lot of organizations that are running the Internet Routing Registry. And the Internet Routing Registry uses a set of objects. The OTNUM uses a language called RPSL, Routing Policy Specification Language, to store routing policies for organizations like network operators and so on and so forth. So basically in the OTNUM, we'll have information about your ASN, information about the prefixes that you are advertising, information about the prefixes, not the prefixes that you are advertising, what you advertise, information about what you are actually, which networks you are actually accepting stuff from them. Route and Route 6 is are objects that are used to specify for each prefix which autonomous system is authorized to originate that prefix. So route is for IPv4 and route 6 is for IPv6. And AS set is what we use to document our customer count. So it's basically when an organization has more than one autonomous system number to manage. So you may be having 2 or 3 autonomous systems for yourself, and then you are having autonomous system numbers for your customers. So you document that using AS set. RUA is actually almost the same as route and route 6, just that we use a certified certification system called the public key infrastructure. So this is an example of route object that you can find out there. If I will stop sharing again, and I decide to share, let's say, my terminal, and I query. If I do whois, I go to whois.afrinic.net. I query the prefix 1.1.1.0/24. You see the information I get here. So I'm getting all the information about the prefix, right? The prefix here belongs to APNIC Labs. So APNIC and Cloudflare DNS Resolver project. So it's a project there at APNIC in conjunction and with Cloudflare. And you can see that I'm having a route object here, right? So this route object basically is explaining that this prefix 1.1.1.0/24 can be originated by ASN 11335. And if you will query this ASN, you can also query this ASN. So it's ASN 13335. All right, it is not with Afrinic. Maybe I can go and look at APNIC. Okay, I am not seeing this. Okay, I don't know why I can see this. All right, so we have the prefix here. Okay, you can see it is sitting at ARIN. Okay, that is it. So if we go back, so another example, you see, when I queried, when we previously queried this whois -h whois.ratdb.net 1.1.1.0/24, you can see here that we actually had like 2 entries. One entry was from APNIC, and another entry was from RATDB. So RATDB is a commercial internet routing registry. So you can actually go there, you pay a fees, and you'll be able to create what we usually call proxy objects. The problem with this third-party IRR is that sometimes they don't update the information, and we have like garbage, a lot of erroneous informations. And this is one problem with the IRR system. So we are running out of time. I will rush a bit here on the RPKI system. So global validation can happen with IRR and RPKI. RPKI stands for Resource Public Key Infrastructure. And we have 2 components actually there. The first component is the PKI, Public Key Infrastructure, and the second component is the resource. So we have resources that are allocated to us by our regional internet registry. And These resources, for us to make sure that we are securely using them, we want to create what we will call ROAS, Route Origin Authorization, on the RPKI infrastructure. So the RPKI has two parts. The first part is the route origin authorization, and the second part is the route origin validation. The route origin authorization is actually you creating your ROAS in the public key infrastructure. There are videos in this slide. I actually have videos here. Yeah, there are videos here. Yeah, these are videos where you can actually see how to create ROAS on the AFNIC website. So the first part, make sure you create your ROAS on the AFNIC portal website, that is myafnic.net. And the second part, when you've created your ROAS, you now need to use this to do the validation in your network. And when doing the validation, you actually need a software that is called the validator. And in terms of validator, we have many validators. Those are the validators that we have. We have Routinator, Fault Validator, Octo RPKI, RPKI Clan, Prova, and RP Steer 2. So I also have like how to install a validator in your network. We have it here on slide 101, so you can refer to it to see how to install. So how it works is, IANA has allocated IP resources to the various internet regional registries, that is RIBE, ARIN, EPINIC, LAPNIC, AFNIC. And at each of these routing regional internet registry, we have an RPKI infrastructure. All right? We have an RPKI infrastructure, and they have installed what we'll call a TAL, Trust Anchor Locator. It's actually a certificate, a self-signed certificate, a parent certificate, a root certificate, all right, that is used to sign all the resources that was assigned to them by IANA. Now, they will allocate part of these resources to network operators in the region, an ISP like, let's say, MTN, Orange, and so on. And when they allocate these resources to all of these operators, the operators need to create what we call ROAS. ROAS, the ROAS comprises of your prefix and the prefix length, the max prefix length, and the autonomous systems that is authorized to originate that prefix. When you create this, the next thing is, when other operators are pairing with you, they will go to the AFNIC repository and they will check if you actually have that. When they check, they will have three possible answers: valid, invalid, and not found. Valid means that the prefix that you sent, the prefix length that you sent, and the ASN are found in the system. Invalid means one of these three is not matching. It's either the wrong ASN or the prefix length is longer than the maximum length. Not found means that there is no ROA that has been created for that already. So when you've done that, you now need to configure your router to be able to use this information to do routing validations. So let's go now to the routing validation. So this is how you configure it. Like, you need to specify to your router what is the address of the validator and the port number. For instance, here we've installed 2 validators on the same server, and they are listening to 2 different ports, 8323 and 3323. And when you've done that, this is also Juniper. When you've done that, when you've specified the address of the validator, you now need to create the policy. So how do you create the policy? This is an example on Cisco. So this policy is actually saying, for valid ROAS, set the local preference to 100. For not found ROAS, set the local preference to 80. And for the invalid, set the local preference to 60. So you see here, we are setting the local preference very low for the invalids. But right now, the advice I give to people is that for the invalids, just drop them. So this is how you drop the invalids, right? You just drop the invalids, make sure that you don't accept them at all. This is for Cisco. And when you've created your policy, you now need to apply it to various neighbors, BGP neighbors. So the same goes for Juniper. And there are some commands to see how you verify your RPKI configuration. Like you can say show IP BGP RPKI servers to see what is the validator what's the IP address of the validator that is actually responding to you. You can also look at the sessions, like right here on this server, we can see that we have 2 sessions, 12.0.1.148 and 12.0.1.160. And you can also view the RPKI unicast table for IPv4 and IPv6. For a specific prefix, like what we have here on screen, 27.56.128.0/20, this is a valid RPKI. So this has a valid ROA that is created. Okay. You can also view an invalid ROA here for prefix 59.144.173 and 0/24. And you can view an example of not found ROA. Okay, that said, I think I've pretty much covered the essential. Part of this could be us trying to demonstrate this on a lab. I will stop here, and if there are any questions, I will gladly answer, and we can have another session to demonstrate the lab. Thank you for your attention.
Thank you so much, Musa. This was very, very informative. I'm sure everybody that has attended here appreciated the knowledge that you've imparted to them. There is a question from Matthew. He says, if I have IP space from different IRRs, do I have to create ROAs on each separately? Can I just do all on one platform?
All right, so if you are having, remember I told you that each regional internal registry is having their own RPKI infrastructure, right? And because they're having their own RPKI infrastructure, the certificate that they have is attached to the resources that were allocated to them. So they cannot sign resources from other regions. So if you're having this, you will have to create ROAS on each of these infrastructures. Another way is you can have your own RPKI infrastructure, right? And then you create ROAS on your own RPKI infrastructure. That is called the delegated mode. And the delegated mode at this moment is not yet like provided by all the regional internet registries. Okay.
Thank you so much. I hope Matthew's question has been answered. I don't see any other questions. So thank you once again, Musa. And I will hand back over to Joshua to close ngPIF officially. Thank you once again to everybody that has attended. It's been a great session. Back to you, Joshua.
Thank you.
Thank you so much, Musa. Thank you so much, Portia. It's been a wonderful last day. So I don't know if someone has something to say. So maybe we have like an open house for the next 2 minutes before we close, and maybe someone has anything to say. Our happy would unmute you and let us hear that. We can take feedback on what's happened in the last 3 days. And if you have any issues, yeah, sure. This might be a good time to have someone help you out. So good. I'm waiting to see if I see anybody's hands up. Oh, great. That's Matthew. Okay, I can hear you, Matthew.
Hey, hi. So it's actually nice to be here, and in fact, actually, I underestimated the power of these snippets and the knowledge sharing. I mean, it's really great. I kind of appreciate it from a refresher, and also from a point of view of some things that you may take for granted, even if you're running very mature networks. I mean, just on reflection, I think this is something that we should do more often, to be honest. And what I actually think is maybe more people should know that it's happening and should find time to do it. I know yesterday I was really pressed for time, but the thing is, just attending some of these things it's so good, because there are so many things that you may take for granted. And to you, Musa, thanks so much for this. There are a few things that from our organization that we just want to clean up, and I think we may actually lean on you, especially on this. I know you gave some how-to something on entity network. I'll look it up. But I just think it could be something very useful. I haven't looked up on the entity website yet, but I think it would be something very useful to just see like the template. We work with lots of organizations, lots of ISPs who are just starting or different levels as customers as well. Sometimes they'll just ask us, can you give us a proper template on how to do this? I mean, of course, we can't just give them how we are doing our stuff, but I think simple templates like this will be very useful for some people want to filter their routes, want to do the best for BGP, for RPK, for MANRS, all these things to do the best practices. I'm really thankful I saw this. I know you went very fast through the configurations, but I think if we get hold of the of the slides, it will be useful at the end. Thank you very much.
Thank you so much, Matthew. So the slides will be shared. The sections also recording will be shared on the website, and an email will be sent out when it's shared. Is there any other person who has something? We still have maybe 2 more minutes. I could still take 1 more too. Maybe it might be a review to let us know that this was successful on your part, or you understood the sections, back and forth. But if there's none, that's not a problem also. Okay, great. There's none. Thank you so much. It's been a wonderful 3 days of my life, your life and our lives on this call. We've had quite a lot of sections. We've had 4 different boot camps. The first boot camp was about no community tools for network operators. We had the second boot camp, and we spoke about the second boot camp. We focused a little bit on BGP. The third boot camp, we spoke about IPv6 integration. And then the last boot camp now, we spoke about MANRS. And then we had a conference where we spoke about what are those things that we need to do in Nigeria when it comes to PNI. It's been quite a lovely 3 days to be with you, and I'm sure that we will keep in touch. We would try to have a mailing list for the PIF for people who are interested, who have attended this event. That way we can be able to share information back and forth on PNI connection in the country. Let me know if you have any issues. Feel free to shoot us an email if you do. If you do have any stuff to tell us, info@noc.ng. And in the next few days, I'll be sharing some information about the PIF with you so that we can all be abreast. Do have a wonderful day, and see you next year in the ngPIF 2022. Thank you so much, and do have a lovely day ahead too. Oh, great. I also would like to say thank you to the sponsors, Flex Updates, Facebook, ISOC, Rack Center, Afrenig, Engine Organized, and you guys have been so awesome. And thank you so much for supporting this event. We are hoping that we'll still see you next year for the 2022 ngPIF and have a better event. Thank you so much, and see you some other time. Grateful.